Pentane was introduced into the aperture of this fracture model made from 2 sheets of sandblasted shower door glass, sealed on the sides and bottom and vented on the top. Heat is applied through the circular devices near the bottom. The temperature within these discs was well above the pentane boiling point, causing a boiling region to extend more than a centimeter from the discs. We'll see 3 segments from this experiment. In the first segment, pentane is introduced into the model and encounters the warmed region. In the second, no pentane is added and a stable dry-out region is formed. In the third, pentane is again added. Here we see pentane seeping through the model, reaching the boiling region. When enough pentane builds up above the boiling region, fingers penetrate and a condensation halo forms both above and below. As more pentane is introduced, the condensation halo increases in size. With even more pentane, fingers deeply penetrate the boiling region. The amount of light transmitted through the models depends on the amount of pentane in the model aperture and the lighting conditions. In the brightest regions, liquid completely saturates the aperture. Liquid films present only on the walls of the fracture appear less bright than the saturated islands, with thicker films being brighter than thinner films. Darker regions indicate where the model is dry. For example, at the top of the model, where pentane is being introduced, we can clearly see the bright liquid drops or saturated islands where pentane completely fills the aperture. These are surrounded by a less bright region in which liquid pentane films are present on the sandblasted glass surface. Towards the center of the model, we can no longer see the saturated islands due to the lighting conditions and the lack of contrast. We can see another less bright, thinner film region between the darker dry glass and the brighter thick film and saturated island region.